So, hello and welcome to a new lecture on statistics, where this time we are going to introduce the concept of combinatorics. So, what are combinatorics? So, usually combinatorics are referred to as the mathematics of counting. And combinatorics basically help us to figure out the total number of different combinations, and that's actually where the word combinatorics comes from, when we perform a particular random experiment. And a typical random experiment is the one where we have n different objects and we choose k out of n different objects. And these objects are equally likely to be chosen. And in this particular random experiment, we can have 4 different situations. So we can have that the order counts when we chose k out of n. We can have no order, so then the order doesn't count. We can have replacement, so we can put back the element that was chosen and put it back in the basket so that it can be chosen again. And we can have no replacement, so we keep the object that was chosen and we don't replace it. And according to these 4 different situations, we have 4 different formulas that basically give us the total number of different combinations for each of the 4 different situations. So if we have order and replacement, we have n to the power k different situations. If we have order and no replacement, then we have this multiplication of n times n minus 1 up to n minus k plus 1. If we have no order and replacement, we have this binomial coefficient. And if we have no order and no replacement, we have this nk binomial coefficient. So in order to illustrate this, we are going to look at a particular random experiment where we basically choose 2 billiard balls out of 3 different billiard balls that are labeled from 1 up to 3. So here we have the 3 different billiard balls. This one is labeled 1, labeled 2 and labeled 3. And we are going to choose k, so in this case 2, out of n, in this case 3 different billiard balls. And in order to see if we recover actually the number of different combinations, we are going to write down, for this rather simple random experiment, we are going to write down the different combinations and then we compare if we actually find the number that was provided by the formula for the 4 different situations. So let's start with the situation where we have order and replacement. So we are allowed to put back the billiard ball that was chosen. And so we are choosing 2 out of 3, so we can have combinations like 1, 2. So we first choose 1 and then a second billiard ball we choose 2. We could also have like 1, 3, so first we choose 1 and then we choose 3. We can have a situation like 2, 3, where we first choose 2 and then 3. We can also have a situation where we choose first 2 and then 1, because this is not the same, because here the order matters, so 2, 1 and 1, 2 is not the same. We can also imagine a situation where we first choose 2 and then 3, or we can have a situation where we first choose 3 and then choose 1. Or, as replacement is allowed, so we can put back the billiard ball that was chosen, we can also have 3 different situations. So we can have 1, 1, because we can put back the billiard ball 1. We can have, 2, 2, so basically 2 times 2. And we can have 3, 3. So what we find here are 1, 2, 3, 4, 5, 6, 7, 8, 9 different combinations. So let's see if with the formula we also find 9 different combinations. So we saw that in this case, in this particular case, n equals 3. So we have here 3 and k equals 2, so 3 to the power 2, which is 3 times 3, which is 9. And indeed, we recover a total number of 9 different situations also with the formula. So then move on to the other situation where we have order and no replacement this time. So no replacement means that these 3 different combinations are not permitted in this particular case, but the other remaining 6 are allowed. So we can have 1, 2, we can have 1, 3, we can have 2, 3, we can choose first 2 and then 1, which is again not the same as 1, 2 because the order matters. We have order. And then we can choose 2, 3, 3, 1. And that's basically it. So let's check with the formula. So as we saw, n equals 3. So we first have 3 times n equals 3 minus k equals 2. So basically 3 minus 2 plus 1. So this is 3 times 3 minus 2, which is 1, plus 1 is 2. So we have 3 times 2, which is indeed 6. So we find the 6 different possibilities in the case of order and the replacement. So then let's move on to the situation where we this time have no order. So the order doesn't matter, but we still have replacement. So order doesn't matter means that this combination 1, 2 and 2, 1 is basically the same. The same for 1, 3 and 3, 1 is the same. And 2, 3 and 3, 2 is also the same. Yeah, so the 2, 3 was chosen 2 times. So here we have 3 and here we have 2. And here we have 3 and here we have 2. So it was the other way around. So we have 1, 2. We have 1, 3. We have 2, 3. And 2, 1 is already included in 1, 2. 3, 2 is already included in 2, 3. 3, 1 is already included in 1, 3. And let's see, we have replacement, so these 3 are allowed as well. So we have 1, 1, we have 2, 2, we have 3, 3. Okay, let's check with the formula. So this time we have the binomial coefficient of n. So 3 minus 1 plus k, which is 2. And then here we have 2, which is equal to 3 minus 1, which is 2, plus 2, which is 4 factorial, divided by k, which is 2 factorial, and n minus 1, which is 3 minus 1, which is 3 minus 1, so 2 factorial, which is 4 times 3 times 2 times 1, divided by 2 times 1 times 2 times 1, which this one simply is simplified, and here we have 1, 2, so we find 6 different possibilities, and indeed we have the 6 different possibilities here. So here we see that the formula corresponds with our intuitive analysis, and then we have the last binomial coefficient, and this time we have no order and no replacement. So order doesn't matter. So basically we have this one here, 1, 2. We have 1, 3. We have 2, 3. And as we have no replacement, we cannot have elements like 1, 1, because 1, once it is chosen, cannot be chosen a second time. So that means basically we have only 3 elements. Then let's check with the formula. So with the formula we have 3, 2, the binomial coefficient 3, 2, which is 3 factorial divided by 2 factorial, 3 minus 2 factorial. And this is 3 times 2 times 1 divided by 2 times 1 times 1. So this is simplified, and indeed we find 3 different possibilities, which are the 3 different possibilities here. So basically that concludes this lecture. If you have questions, please leave a message and your question in the comment section below. Hope this video was of some use for you. If you like more content like this, please like the video and subscribe to my channel, and see you in the next video.